Hi guys. Sorry I can't be there again, but I am going to teach you your first lesson in the second half of Unit 1. We're going to talk about a graph called hyperbolas. Before we start talking about the graph, I am going to review some other graphs you should already know. And then I'll kind of go through what a parabola is and how you get a graph of it. Also, grades went in. I don't have your quiz grade in there, but I plan to grade it today so you can kind of check that out and make sure you see what you got. Otherwise, I'll be there tomorrow to go over it. As I'm doing this lesson, I want you to have graph paper and practice graphing the graph with me and following along. So I'm going to switch over. I also think I may have solved the sound problem, so hopefully you're hearing me better. I think before it was switching to my hover cam mic, which doesn't catch sound as well, so hopefully this will be smoother. So let me switch over and we can start. So here's my paper. Let me double check which microphone I'm on. All right, so this is going to be lesson 122. I think I need to adjust something real quick on my video. All right. Okay, so lesson 122. And we're going to investigate parabolas. Or not parabolas, I'm sorry. Hyperbolas. So hyperbolas you may not have worked with much. So I'm going to teach you what they look like, what their equation looks like, how you graph them, because they are very different. But before we get into that, I want to go over the graphs that you've probably done before, just so we kind of make sure we know which one's which. So let's talk about those. Because after a while, you should be able to see an equation and kind of know what that graph should look like. Or if you see a graph, you should also be able to kind of identify what the equation might look like. And as we work through this semester, we'll really kind of get a better understanding of all our graphs. So all these graphs I'm going to go over are ones that you should have covered at some point in Algebra 1 or so far in this class together. If you forget some of these, that's okay, but hopefully you'll start to remember as I remind you of them. So the first graph you probably ever learned about was a linear graph. So you should always know that if you have equation like in y equals mx plus b form, that's going to look like a line. So linear is line. Linear just has an x. There's nothing being done to the x except maybe it's being multiplied by a number. It's not raised to a power. Nothing else is done to it. And just to give you a little sketch so you have a visual, linear would look something like this, a line. So we should always know what a line looks like. We will actually work with linear equations tomorrow. Spend more time on those. But these are the ones you should probably have the most understanding of because you've probably worked with them the most. Another one you should have a decent understanding of, or at least its shape, is quadratic. And you may not know quadratic by the name quadratic, but it's a parabola. So an equation of a parabola is always an x squared equation. You could have x squared being multiplied, you could have another x and a constant, but in general, if you have x squared, that's an equation of a parabola. And you know that if you have an equation that has x squared, you know what your graph should look like? Hopefully you do. Your graph should look like a U. That's our parabola. So the graph of a quadratic equation is a parabola. That's our parabola, that's our line. So these are ones you probably should have worked with before. Another one you should have worked with in Algebra 1, but you may not be as familiar with, is an exponential graph. So exponential graphs are kind of different. Their equation is always y equals b to the x. B always has to be a number greater than 1, or less than 1 greater than 0. B cannot equal 0, and B cannot equal 1. And B is positive, I should add that. But these graphs kind of look like this. They get big real fast. So they get real small, 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 and then they get real big, 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 big. So if you ever heard someone say like it increased exponentially, that means it increased really fast. So just an example of what that equation would look like, it might be like 2 to the x. So it's 2 to the power. So basically you're taking your number and you're timing by 2 every time, and that's why it gets big fast. And then the last one is one we've been working with in class a little bit. We've done some graphs. We've worked on them in some of our homeworks. Is the square root. And if you remember when we've done some of these in class, the square root function always has one endpoint. So like has an endpoint and then it goes in one direction. So one of the goals is that of this semester, this session we're together, is that when you start to see equations, you can picture what the graph looks like. Or if you see a graph, you can be like, oh, I know this equation should look like this because this is the graph of this. So just being able to have a better understanding, kind of knowing graphs. So today we're going to talk about a new graph that that you are going to learn about that you may not have much experience with. And it's called a hyperbola. And now we'll actually talk about the hyperbola. So hyperbolas are kind of different. They're not as friendly as like a linear graph or a parabola, but they're not bad. So in general, the equation for a hyperbola looks like this: 1 over x minus h. And h can be any number. So x, if you notice, this is like it's a quantity in the denominator. It's always 1 over, and then you have a quantity down here. To get this big fraction bar, you use the divide button on your calculator. We have to choose an h. And h is what you call a parameter. A parameter kind of tells you where the graph is located. It doesn't change the shape. So h will kind of decide where the graph is located, but all of these graphs will have the same shape regardless of what number h is. So what I'm going to do is I'm going to choose an h value, and I'm going to kind of walk through how you can graph this, what you'll see when you plug it in, how we can get a good graph, because the table isn't very friendly. And I'll explain that as we look at this. So first I'm going to choose an h. I'm going to choose h is equal to 5. And so if h is 5, then our equation looks like 1 over x minus 5, because the equation already had the minus in there. I'm going to try to make a habit of putting this in parentheses, because when you type this in the calculator, you're going to have to put that in parentheses to get the correct graph, because you want 1 divided by that whole quantity. So what we will first do, and I'll kind of put these into steps, is we're going to put it in our y equals. So I'm going to take out my calculator. Again, sorry, my calculator has smudges on it. I need to clear out what's in there. I'm going to hit Zoom 6 just to make sure I'm on my standard window. And then I'm going to type this in. 1 divided by, and in parentheses, x minus 5. So after you type that in, you want to look at your graph and table. I always look at my graph first so I know where to look on the table. So when I hit graph, I always look there because that tells me where I need to look on the table. So this is a weird looking graph. Depending on your calculator, you may not have this line that's right there because there's not actually a line in the graph. The graph is actually this little curve and this little curve. This graph is actually like disconnected. So it's not like where it just flows like a parabola. It's not connected. So this one's a little weird. And if you notice, it's over here, like halfway. Remember this distance is 10 because I set it to the standard window. So this graph is kind of centered around 5. So when I go to my table, I don't need to look in the negatives. There's not much going on over here. So when I hit second graph to go to my table, I want to kind of look in the positives, which I'm already kind of there. Now, if you're looking at this table, you might notice, and I don't know if you can see my calculator well, but if you plug it in yours, plug this in, you can see this has a lot of decimals. So we have decimal, 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 decimal. Then we have -1. Then the calculator has an error. And then we have 1. And then if you look, we have decimal, 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 decimal. So the biggest number in this table in our Y's is 1. So because the biggest number we have is 1, we want to scale this, when we graph this, we want to scale our Y-axis in something smaller than 1 so we can get a good picture. So I'm going to scale, because we have numbers like 0.2, we have a 0.5, I'm going to scale by tenths or 0.1. So I'll show you how that looks. I'm going to set this up. Now, if you heard me, I said scale the Y-axis. That's my up and down because the Y's are the ones that are all decimals. These are still going by ones. So I can keep that by 1. So this could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you notice when I scale, I didn't write every number. I don't really have much going on back here, so I don't need to focus on that. But the Y's are where we want to go by tenths because 1 is our biggest number. If we went by ones, all our points would be between this tiny little unit. And we want a good picture of our graph, so we're going to scale it by tenths. So this would be like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Anybody know what comes after 0.9? Don't say 0.10, it's actually 1. And then we do the same thing in the negatives. -0.1, -0.2, -0.3, -0.4, -0.5. And -1. So this is almost like we're zooming in a little bit so we can get a good picture. So again, the reason I scaled these by values less than 1 is because our values in our table were decimals. We have 0.5, 0.333, 0.25, 0.2. So we want smaller numbers so we can actually plot those points. If we would plot those, they would all be between here if we didn't scale this differently. So if you need to pause this so you can finish up your graph, you can do that. Okay, so the next thing you do after you have this set up is we're going to plot the points. And to get the best graph, you always want to plot points that kind of surround the error. So if you see this error, the error is at 5. If I were to change my H to a different value, then my error would be at a different spot. So basically the best route would be to graph 5 less than whatever my H is. So in this case, I would graph like from 0 and then graph all the way to 5 more than whatever my H is. So I'd graph all the way to 10. So plot points, and I'm going to write what I just said. 5 less than H to 5 more than H. So for example, since h equals 5, I'm going to plot 0 to 10 because 0 is 5 less than 5 and 10 is 5 more than 5. If my h was like 7, I would go from like 2 to 12. That would give you the best graph because your graph is always going to kind of be surrounding whatever your h is. So I'm going to plot this. Again, if at any point you're still writing or you need anything, you can pause the video. So I'm going to start by plotting the 0 point. And my 0 is negative 0.2. So 0, negative 0.2. Remember, these are 0.1, 0.2, so it's right here. The next one is 1, negative 0.25. One second, I'm just trying to see. Negative 0.25 is like halfway between 0.2 and 0.3. So it's a little bit more. So it's halfway to the next one. And then the next one is 2, negative 0.333. That's a little past 0.3. So when we go to 2, and we go to 1, 2, 3, it's a little past that. Not quite halfway, a little more. And then the next one is 3, negative 0.5. So we have 1, 2, 3, negative 0.5 is right here. And the next one is 4, negative 1. Negative 1, remember, is all the way down here. It's not 0.1, it's a whole number 1. So that's what we have right there. And if you go back to the graph, that's this part right here. We zoomed in, so it will look a little different because we scaled our graph differently. If you notice 5 has an error, that means we don't plot anything. That means there's no point at 5. So we skip 5. If we go to 6, it's 1. That's positive 1 all the way up here. So 6 is at 1. 7 is at 0.5. 0.5 is halfway up. So remember 0.1, 2, 3, 4, 5. And if you notice, it's kind of the same points, just they're positive. So now 8 is at 0.333. And remember, that's a little more than 0.3. 9 is 0.25. This is 0.2. 0.25 would be halfway up. And then 10 is 0.2. So 1, 2. So right now, this may be like a little confusing. But what this graph does is it curves around. So we're going to connect these. These should curve and these should curve. One thing this graph doesn't do, and it might be hard for you to see it here, is it doesn't actually touch the x-axis. So this graph will get close to it here and here, but it won't ever touch it. So I'm going to connect these and they should be curved. I'm going to connect. And they don't actually touch 5 either because there's an error. So when we come down, this will keep going down. This will keep going up. And this one will go this way. And go down. So that's what this graph looks like, but it's disconnected. So we have like a curve here and a curve here. And I'm going to kind of explain why it's disconnected and why we have an error. So if you're looking, and if you're still graphing, you can pause right now. If you're looking at this equation, this is a divide situation. So if you're looking at why there's an error at 5, if you were to plug in 5 here, that would make the denominator 0. And if you remember, you can't divide by 0. So it's not possible to take a quantity and divide it among 0 people. There's nowhere to put it. So, and if you need to see that like in action, if I were to do 1 divided by 0 here on my calculator, it says error, divide by 0. You can't do it, which is why there's an error there, because there's not an output when you plug in a 5 into this equation. So just a little side note that might help you remember, but the error is always the x value that makes the denominator 0. In other words, the error will always be the h. And so in this case, our h was 5, that's where the error was. If our equation, we chose h to be 10, our error would be at 10. If we chose h to be -3, our error would be at -3, because that's always going to be the value that will make your denominator 0, and you can't divide by 0. So we've been talking about key points and key characteristics. This graph has a key characteristic that none of our other graphs had that we've worked with so far together, and it's called an asymptote. So if you've never heard that word, it's kind of a silly word, but this graph actually has 2 asymptotes. So an asymptote is a place that your graph approaches, but it never actually touches. So if you remember, I said it doesn't touch the x-axis. So this graph will get closer, 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 but it will never actually touch the x-axis in both directions. It'll also get really close to 5, but never actually touch 5 because there's no value there when x is 5. And so that's what an asymptote is. I'm going to write that down. An asymptote. So it's kind of like an imaginary line, but it's a line the graph approaches but never touches. And on these, you'll have a horizontal asymptote, so one like this that your graph never touches, and a vertical asymptote that your graph never touches. When you are identifying these asymptotes, so like your vertical, the vertical one is just a place that the graph, it's like where it passes through the x. So the equation is always written as an x equals. The horizontal line just passes through a y. So that asymptote is always written as y equals. For the hyperbolas, we're going to work with our horizontal asymptote is always going to be y equals 0 because it's going to be the x-axis. Our vertical asymptote always depends on where our h is, and it's always where your error is. So that's kind of easy to find. I'm going to kind of label that on our graph. So if we're looking at this graph, this like place where 5 is, you kind of think of it as an imaginary line. And my graph, if you saw in my calculator, actually draws that in. That's why this graph on the calculator has that little line there. It's not really there, it's the asymptote. So it's kind of showing you it kind of approaches that. Some of the graphs don't do that. So this imaginary line right here is your vertical asymptote, sorry. And because it's also, the vertical asymptote is always where the error is. So since our error was at 5, we say our vertical asymptote is at x equals 5. Now, this graph also never touches the x-axis. And that's because this quantity can never equal 0, because you can't take 1 and divide it by something and ever get 0. So that's why it never touches there. The only way to divide and get 0 is if you have 0 divided by something, but this will never be that. So that's why it never touches. So this place here, hard to see my line I just drew, but we can pretend it's there. I'll draw it a little bit above it. That's your horizontal asymptote. and we call that one y equals 0. This graph will never, so the graph is the blue, that's the graph. So this graph will never touch 5, x equals 5, and it will never touch y equals 0. So those are your asymptotes. So this graph wouldn't have any x-intercepts because it never touches the x-axis. It does have a y-intercept. This graph doesn't have endpoints. It keeps going. It doesn't have a vertex really, but it does have a domain and range. And if you notice, this graph will keep going to the right, it'll keep going to the left, it'll keep going down, it'll keep going up, but except for one value. So it'll keep going left and right, except it doesn't have a value of 5. It'll keep going up and down, except it will never touch 0. So when you say your domain and range for a hyperbola, instead of saying what it can be, you just say what it can't be. So for our domain for this, we just say x can't equal 5. That would be your domain. Because x can be anything, because it'll keep going left, keep going to the right. So normally we might say, oh, it goes negative infinity to infinity, except it never equals this value. That's where your error is. So you can just say x can't equal 5. And by saying this, you're saying it can equal everything else but 5. So that's our domain. And our range is kind of the exact same thing. Like this will keep going down, down, down. It'll keep going up, up, up. So it can be any y, except it will never equal 0. So you can just say y can't equal 0, which then tells us y can be anything else but 0. And typically you can figure that out from your table. So wherever your error is, that tells you what your x can't equal. And then our hyperbolas will never touch this. So the range will always be this. The domain will always just depend on what your h value is. So you put a lot of things on here. At any point, you can kind of rewind this and go back. Your assignment is to practice this. So I have it posted on the classroom. You're going to create what's called a Jamboard. So I'm not sure if you've ever made a Jamboard before. We're not going to create one, you're going to add to one. So I'm shared with you a, sorry, I lost my train of thought. I shared with you a Jamboard. And what you're going to do on graph paper is you're going to choose your own h value, so a number other than 5, because I already did 5, and you're going to create a graph just like this. So again, follow these steps. You're going to put all these in. You're going to put it in your calculator, scale it the same way we scaled this, plot your points, create your curve for your hyperbola, and identify your asymptotes. So you're going to do that on graph paper. And then you're going to take a picture of that. You can take a picture with your Chromebook, so you can hold it up to the camera and take a picture and save it. And then you're going to add it to your Jamboard. And I'm going to show you what the Jamboard looks like, but it's loading. So give me 1 second. Okay, I'm getting, so I'm gonna share my screen with you. Okay, so on the classroom, you'll see this. Let me scroll this way. So each student will choose a value for h, and draw a complete graph, just like we did in the notes. After you complete your graph, you'll take a picture, save it to your Google Drive, and upload it to the shared Jamboard. And I'll show you what a Jamboard is in just a minute if you've never seen one. Make sure that you write your equation of your hyperbola on your graph so it's visible, and identify your asymptotes just like in the notes I did. And then you'll insert a Post-it onto the Jamboard with your name. So I'll show you what that looks like. So if you click on this, this will take you to the shared Jamboard. And on the left, it should pop up in a minute. There are things where you can insert stuff. So this icon right here would be to add an image. So after you take a picture of your graph, if you click on this, it should pop up. So the image should come up. You can go to, you can browse, it should be in your Google Drive. So then you insert the image. You may have to resize it. I don't think I have a picture of one offhand, but maybe I can show you a different picture I can plug in here. So here's an example, I think, of a student did one. So if I insert this, so this is pretty big. Since we're all posting to the same Jamboard, this picture is not very good. Hopefully yours is better. I can resize it. You can also rotate it, so you could like turn it if you wanted to. Okay, click off. And then I said to add a sticky note with your name. So these are the sticky notes. So if you pop open a sticky note, you can pick the color and then you could put your name. Maybe I like this color. Oops. And then you can move your sticky note where you want it. You can change the size of your sticky note. And then you could also rotate it if you like. However you like. This picture is not good. So if you do this, please choose a good picture. Make sure it's visible. And try to delete these things off our board. But that's all you're doing. So that's how I know if you've done your homework, is it's inserted on here. If you don't like the sticky notes, you can add a text box for your name. If things are not clear on your graph, like the labels, you can add a text box to put under your picture. When you click text box, you just start clicking and then you can type. So you could say where your asymptotes are if it's unclear on your picture you add. But that is your assignment. It will be on the classroom. All of you will be posting to the same Jamboard. It's a shared one. If it gets too crowded, so maybe people beat you, you can add another frame. So we could have different slides and then we can look at this. All the graphs should look similar because we're graphing the same type of graph, but they shouldn't be exactly the same because you're each making your own. So I would like to stop sharing. So again, go back through if there's any parts of this you missed, but your assignment is to create this graph, but with a different H value. So you should have a different equation. If you want to choose a negative, you can. Just make sure you still have them, like them. If you want to, you can put minus. So if you choose a negative number, it would be like x minus -5, or you could put x plus 5. So a negative would actually make that plus, but you can choose negative numbers. I just wouldn't choose anything really bigger than 10 or smaller than -10. You can, but then your graph's you'll have to adjust your graph to make it visible. So that's what you're doing. Help each other if you need help. You can send me a message if you need it, but you're just making a nice graph. So get your graph paper, go through these notes if you need to. Let me know if you need anything, and I'll see you tomorrow.